Everyone. So I'm Hayden, and I was working on machine learning. So basically, I've been creating a framework for machine learning and VL. The idea basically being that quite often, obviously, we want to basically work with machine learning because it's quite a new technology. Very interesting results can come from it, but we don't always have to learn Python to basically do so. We don't want to have to make some mad Python bridges just to kind of get basic results into VL. So the idea instead is that we just program it in VL. And furthermore, we make it easier because we can actually see what our kind of like our algorithm actually looks like. And we can just change it and tweak it on the fly. And we basically just run it. So for the first day, I was basically kind of asking people what they themselves were actually interested in. Some people were kind of interested in sort of like just finding out what machine learning kind of was. Some people were interested in the idea that as a base technology, you could kind of create general purpose algorithms that could do multiple tasks. Other people were interested in the idea of this idea basically of not having to have a bridge. Some people were interested in the idea of like image tracking. I think it was, where is he? He's around here somewhere. But some people were interested in the idea of tracking and detection and images. Some people were interested in ideas about gesture recognition as well. So what I did is I showed the current state of the actual library, which is pretty close to being fully there. It's quite stable. We can do different inputs and outputs, so you don't have to write your own inputs and outputs for the data that you want to have. You can have vectors in there, images in there, colors in there. Can't do text yet, but that's something that's coming along, and then I think by then it'll be quite useful for a lot of people. What else do we have? So we also have modules as well. So the idea is instead of having to actually write your whole algorithm yourself, you basically just take a module and you basically just plug in the data that you want, let it train, get the model back out again, and just evaluate it. So again, it can be something that makes everything much easier for users to actually have. So what else is there? Okay, let's move forward. There were some questions like, for instance, when am I going to release it? Got to that. Questions like, can you bring in external models and actually run them as well inside of VL? Both those two things, the answer is, actually no, not both of them, but for both of them, it's coming, actually, the answer. But the release one in particular, I think I'll come to that one a little bit later as well. I think it's an important issue, but it's also about the way that you want to use it. Okay, so on the second day, I was working a lot with Matthias and Marco, and we're kind of going through I was sitting down and going through how to basically make your own algorithm with the system. And in terms of the actual nodes that you use, it's not really that complicated. You basically just have to have an input, then you have to understand the layers that you're putting in, then a trainer at the bottom, press train. However, there is still some understanding that you need to have with regard to how machine learning works, like how big should your actual data be as you're passing it in. I guess things like what kind of cost function should you use. They can be quite complicated and kind of niche things, but even then, the library should actually get rid of the kind of headache of where they can put it in the actual code in the first place. So it should make things a lot easier. But during this time, it was quite nice because I got a lot of feedback about what was missing in terms of documentation. And like my notes here basically are the three most important things are documentation, and that there's an immediate use case which is signal processing. So documentation part I'm going to come back to in a moment, but first of all, when I was working with Marco, it was quite nice because he had a very distinct problem that he actually needed to solve pretty soon, which was that he was trying to basically find 3 points, like 3 triangle points in a field of possible dots around the space. Now what we knew was that the triangle points basically had like blobs on them, and that we knew that basically they had a very set structure, so that wherever they basically were in the space, we could always basically kind of like we should be able to actually find them regardless. So what we did is we basically just put in the data. I think we put in like 2 frames worth of data from both sides for 2 frames worth of data for the actual input of all of that information, and then basically just the output, or what the correct output should be for this information as well. Now, although we didn't actually get the answer that we wanted, not yet anyways, it's basically just about him just tweaking, playing with it, and he'll basically end up getting the actual bundle that he wants to get. So for him, I think we sat down for about 15-20 minutes or so to actually build the actual algorithm, to build the actual program. We spent maybe like 5 minutes, 10 minutes just figuring out how to actually get the right kind of data in, which we actually just patched really quickly, and then we just kind of like just set it. We basically just literally just recorded basically the actual input data for both sides, and then we just edited it in. So again, it's very, very simple. So it means within the actual patch you already got, you can actually just create a little recorder essentially, and obviously add it to your actual data set. But what was quite cool was, yeah, so all that stuff just said is nice, and then the thing is that it's easy when you know how. This is the problem basically. So the documentation needs to be clearer. Although the actual patching itself is really nice and clear, the actual documentation needs to be better. It's a very, very complicated subject. This is something that we were discussing earlier. If you're going to basically give somebody a framework that's this complicated, you may have to actually teach them to some extent how to use it, not just on the level of this is the node that does blah blah blah, these are your inputs, etc. But tell them conceptually how this actually works. There you go. How it actually works in terms of like what is a convolutional layer, what does it actually do? What is a dense layer? What are the neurons within it, which are completely conceptual? These things are like kind of big questions that need to basically be added to the actual system. So what we were discussing in particular earlier basically was things like the terminology, in a way that the user has to actually learn the terminology, because unfortunately it's out there. It's not just within my system. It's familiar terminology for machine learning. So unfortunately, though it's quite academic, it needs to be kind of like brought in. We had ideas along the lines of things like notebooks. I don't know if you've come across like Jupyter notebooks before, but essentially what they do is they have the code and the documentation all in one set. And so what that allows you to do basically is actually like go through your code, but also get this very good explanation about what's actually happening within it. And in VL, what it could be is that you actually have images, or you have data readouts. You actually have the graphs actually of the data as it's basically being processed. So you actually find out much more. It's like it'd be a much richer documentation tool. So as a learning tool, I think VLML could actually be really, really strong for learning machine learning. I think I'll stop there. There's other stuff that could be said, but I think I'll stop there and take some questions. If there are any.
You should mention Bertrand's quote.
Oh yeah, that's true. What did he say? He said something wonderful. He said, it's the source of endless euphoria and excitement. I can't disagree with him there. I can't. It's true.